The first video of this week discussed about some tools that we use for software development. You are also introduced to version control systems. In this video, we will discuss version control systems in more details. So first, let's understand what are the problems that we are trying to solve here. We know that software developers work in large teams. So how to handle concurrent changes to a project by the team members? How to manage several versions of the software? Is keeping multiple copies of source code a way to go? How to track the changes, including who did those changes over time. So we need a way to do all this efficiently. Let's understand this problems with examples. Consider that several developers are working on the same project. One of the developers made some changes to the code that caused a failure to the system and the system refuses to start. In this case, other developers who are working on the same project, they may not be able to test their new code changes. So either you identify and fix the issue immediately so that other developers don't face issue because of this failure. But this could take a long time because you don't know how much time it will take to debug the issue as you don't have any change history recorded. The second option is you just roll back the previous changes that caused this failure and take back the system to a previously running stable state. But how to do that in the absence of a system that supports this? That is a task that we don't know how much it will take. So let's come to the second problem. Consider a company that has hundreds and thousands of clients of a software system, and every client may have a specific feature requirement. If not every, many will have it. So for every specific feature requirement that other clients don't need, the company will create a new version of the software, and these versions needs to be maintained and stored. So again the same problem, will you store complete copies of these of the code base for every version? So we definitely need a tool to address these issues, and that is where version control systems are helpful. So a version control system is a system that helps in tracking and managing the changes to the source code or other documents and maintaining the versions of the code. In software engineering, version control systems falls under software configuration management. So the version control system does not make a copy for each version. They have their own mechanism either through diffs or through snapshots to maintain several versions and other history. Okay, so the features that a version control system offers are tracking and managing changes to the source code over time, either through branching, merging commits, or through some other mechanism. Maintaining different revisions of the source code. You would have observed uh, version numbers for a lot of softwares like 1.2, 1.3.1, 2.0, or something bigger. So these are all different or newer versions of the software and labeled as numbers. So version control systems also helps in maintaining change history that includes tracking who changed what and when and other details. So there are additional features the newer version control systems offer nowadays. Actually, these features are integrated along with version control systems, including comparing different revisions. They provide tools integrated for reviewing the code changes, tools to track issues in your software, and providing ways to collaborate development in team. So why are they important? Obviously, they increase productivity because developers can focus on their sole task of development rather than worrying about all the development operations. They support better communication and collaboration through several tools that we have just saw. They save on space on multiple revisions by storing snapshots or through diffs. And ultimately, This results in better efficiency even as teams scale. So nowadays the question is not whether to use it or not, everybody use them. The question is which one to use. So let's come to types of version control systems. The first one is centralized version control systems. In these kind of version control systems, there is a centralized repository maintained on the server that everybody shares. So entirely based on client server model, a person who want to make changes checks out whole or part of the repository, make changes, push back the changes to the server, and they are done. Examples of these kind of centralized version control systems are Perforce, SVN. They are still in use in a lot of organizations, but they are highly dependent on the server. If anything goes wrong on the server, the entire development could halt till the server is up and running again. You may even lose entire history or repository if the backups are not configured for the repository on server. The second type is distributed version control systems, which are more popular nowadays. In this, entire repository is mirrored locally. That includes the full change history. A centralized repository hosting service could be involved, but the complete dependency is not on that. Basically, everyone owns their own local copies of the repository. So let's understand about distributed version control systems through one of the most popular distributed version control systems, that is Git. So why is this so popular? Because this is free and open source. Originally, this was authored by Linus Torvalds in 2005 for development of Linux kernel. Since then, it has evolved a lot, and the version today you see has a lot more features. The focus of Git is on speed, data integrity, and working on multiple tasks simultaneously. How these are achieved? Let's see. We already discussed that entire repository is mirrored locally. So if you have everything mirrored on and you have multiple copies of the repository, you achieve data integrity, and it's very hard to lose data because you have multiple copies. Now the second point is nearly every operation is local because everything is mirrored, including the change history. So for example, if you want to check some previous change and who did that, you don't have to talk to server for these small operations. So hence you achieve speed. And we'll see later that Git supports multiple branches as other version control systems. So they provide parallel development. Now, how to use Git? So there are several ways you can use Git. The first one is through command line. You can install Git on your machine, whatever operating system you are using. Git is available for it, Windows, Mac, or Linux. With IDEs, so there are a lot of IDEs that have Git integrated by default, or you have plugins to integrate IDEs, Git into IDEs. The third one we'll look at is the GitHub portal, because that is what we'll be using for our projects also. Okay, so GitHub portal is the online repository hosting service that gives you a graphical user interface also to use Git. Now let's see the Git workflow. So this is a simpler workflow. The file can be in three stages: modified, staged, or committed. After you modify the file, you move it to the staged area. To the staged area means you have marked the file to be committed, but it is still not committed. Committed means after you commit it, it means that the changes are committed to the local database. Now, why do we have this staged concept here? So suppose you have modified a lot of files, and some files are modified just for testing, to help test the new changes that you are doing, but you don't want to put those changes to the your master branch. So in that case, you will move to staged only those files that you want to check in. Okay. Now let's see the commands to do these. Firstly, you have two ways. First is either you create entirely new repository. For that, the command is git init. This will initialize a new Git repository in whatever current working directory you are. After that, you add some files in the initialized directory. You have some files that are in modified state, we call. After that, we'll use the command git add file name. This will move the files to the staged area. After that, the command is git commit with a message that describes the commit, that you can refer to this message to understand the details of the commit later on. So after, this command will move the all the stage files, the changes to the database. The other way is that if there is already an existing repository and you have joined the development on that repository, you will clone that repository to your local machine. The command is git clone URL, then the directory you want to clone it to. After that, the same procedure, you can make changes to the file, do a git add to move files to a staged area, and then commit to push the changes to the database. After that, you can do a git push to push the changes to the remote repository, because currently till now you are working on your local repository, but when you are done, you can push those changes to the remote repository using git push. But you are not alone working on that repository. What if while you were working, somebody else made some changes and you want to incorporate those changes from remote repository to your local repository? So the command to do that is git pull. This will fetch and download changes from the remote repository that are not in your local repository and update your local repository. There could be conflicts. We'll visit those things later. So let's see some more git commands. Get status. This command shows you the status in the working directory and staging area. Once you commit the files, get status won't show anything about those files. Get diff is a command that you can use to see the changes between commits and working tree. Then next command is get reset head and file name. Once you have staged the file name and you decide not to include it in the commit, you can use this command with along with the file name to remove that from staged area. To once you have committed a file but not yet pushed it to the remote repository and you want that file to be removed from the commit, the command to do that is git checkout file name. There is another use of this command that we'll see later, but instead of file name, the option will argument will change. The next command is git log. This could be very useful. This is used to check the commit history. Let's see the workflow involving the remote branch also now. So firstly, you have mirrored the remote repository as a local repository using the git clone command. You make some changes, then you do git add. After that, you move the files to staging area. You commit the files that you wanted to add. After that, the git push this will push all the changes to the remote repository. Then again, you want to make some more changes and you want to check out the latest copy of the remote repository. You do a git pull. The git checkout arrow at the last, it shows the workflow where you had some files in the commit. Those are committed to your local repo, but you don't want to push them to remote repo. That so this git checkout command is used along with the file name. This will bring the file from the committed state to unchanged state. Now the workflows that we have been discussing describes the workflows that involves only one branch. But Git provides a way for developers to work on multiple tasks simultaneously and also multiple developers to work simultaneously. Multiple developers are working on different tasks individually. Also, the same developer can work on several tasks simultaneously. How do they do it? They do it through branching. You can create multiple branches in Git, but still you will need a way to bring all the changes together, because ultimately you are building a software and you want to bring all the changes and create a build of the software that has all the changes that you desire. Okay, so we have the concept of branching and merging. What is Git branching? Branches are independent versions of repository. They are the mechanism to diverge the work from the main project line. So technically, it is a pointer to a commit or a snapshot in Git. Default branch in Git is named as master. So whenever you do the initialization, a default branch named master is always created. So consider that master branch as a main project line. But everybody cannot work on the same branch. Again, the problem will be same. How to manage conflicts and all the other issues that we discussed initially. That's why every developer creates a branch of their own based on the latest master commit. So you can Git provides a way to create multiple branches and work on several tasks simultaneously. For example, git branch feature 1. This command will create a new branch named feature 1 from the base branch you are working on. The command git branch will list all the local branches that are available on your working repository. So now, as discussed, this is the second use of git checkout. If you use the command git checkout with the branch name, your working branch will switch to that branch. For example, git checkout master will switch to master branch and git checkout feature 1 will switch to feature 1 branch. The git checkout command can also be used to create a new branch. If you supply -b option along with git checkout branch, it will create the branch if it does not exist. So now merging. So merging is a way to combine changes made through one or more branches to a single branch. As we saw that a lot of tasks are being completed through branches, but you need a way to combine all the tasks into a single branch that can be used to generate a software build. The command to do this is git merge feature 1. This will merge the branch feature 1 to the currently working branch. So let's see an example. So you are working on a new user story. You created a branch named feature 1 to work on that user story from the branch named master. Then you make the requirement changes to the files and merge these changes to the master branch. So the commands are on the right side. The first command creates the branch feature 1. You make some changes. After that, git add. Suppose only one file was changed. You add that file to the staged area. You commit the changes with some message. After that, you change your branch to master branch use through the command git checkout master, and then the command git merge feature 1 will merge the changes in feature 1 to master branch. Now your master branch is moved to another commit and it has the changes that you did through the branch feature 1. But here this scenario we have created only one branch, but you can create more than one branch and work on several tasks simultaneously. Here we are talking about the same developer. Now let's see branching and merging through a scenario that involves more than one branch. So the scenario is You created a new branch named feature 1 to work on a new user story. You make some changes to branch 1, but you have not yet merged those changes to the master branch. Before merging, and you are still working on the user story, you have not done the complete changes. There is a priority issue that was reported and that was assigned to you, and you have to fix that immediately. So what you will do, you will create another branch named issue p, say, to fix this issue. You make changes to fix the issue and you merge the branch issue p to master. So the issue is fixed, but whatever you are working on, those changes are in the branch feature 1. You again switch back to branch feature 1 and resume your work that you are working on the user story. Now let's see the workflow of this scenario that we discussed. The current branch status before starting work on your user story, consider the master branch is on some commit C2. There are two changes done in your project and you are on the master branch, and the commit master branch is on C2. You created new branch named feature 1 from master branch. The feature 1 will be on C2 based on the commit C2. Now you make changes to feature 1 and commit changes. So a new commit will be created. So let's name it that commit as C3. Now your feature 1 branch is pointing to the commit C3. Now as we have seen in that while you were working, there was a issue reported and you started working on that issue through the branch issue p. You created a branch issue p, you made some changes and you committed those changes through branch issue p. So another commit will be created for that. Let's call it C4. So your issue p is on C4, feature 1 is on C3 and master is on C2. After that you are done fixing issue p. So you have tested your changes, those work. So you will want to merge those changes to master, the changes in the branch issue p. You do that by the commands git checkout master, then git merge issue p, and then you delete the branch issue p using git branch -d issue p. The key should be small in this command. Okay, now the master will point to C4. It is moved from C2 to C4. Now the changes in issue p are merged to master, but those changes are not available in the feature 1 branch because feature 1 branch was created from master when master was on C2. So we say that now master is ahead of branch feature 1 by one commit. Now let's try to merge let's try to merge feature 1 into master. So now you switch back to your user story task. You make more changes and then you merge feature 1 to master using the commands git checkout master, git merge feature 1. In this case, Git will do a three-way merge if there are no conflicts. Else, we'll have to resolve the conflicts and then do the merge. So, why are we talking about conflicts here? So, as we have discussed in the last slide, issue P made some changes and a new commit was created as C4. Suppose there is a file named x.py that was changed in issue P as well, and you have changed the same file in feature 1 as well. So why after that when you will be trying to do a three-way merge, if the same file is changed in C4 and C3, it won't know which changes to keep. In that case, there will be conflicts and you will be asked to resolve the conflicts if Git cannot resolve them. Now let's see what is Git rebasing. So Git rebase command is used to incorporate changes from one branch to another. Let's understand why do we need this command through a scenario. It is the same scenario that we just saw, just that after step 5 there is a small change. So till step 5 the scenario is same. You create a new branch feature 1 to work on a new user story. You make some changes to the branch. a priority issue was reported and you have to fix it immediately. You switch to another branch, issue P, and you start fixing the issue. Just to note here, you add a function, remember function 1, fun1 to the code through the branch issue P to fix the issue. Now consider the scenario when you switch back to branch feature 1 and resume your work on your user story, you realize that you are doing something wrong, and now you need to call the function fun1 in your user story implementation, that is in the branch feature 1. So fun1 code, the function fun1 was added through the branch issue P. Now those changes are not available in feature 1 as we saw in the workflow. So what do you do? The solution here is to do a git rebase. So generally speaking, even without fun1 being there in the branch feature 1, you can call that function and you can make the code changes and you can merge it to the master branch. But the problem will be if fun1 is not available locally on your feature 1 branch, you won't be able to test the changes because it will give an error when your code will try to call fun1. Okay, so to actually, if you want to test the changes, you will have to do a git rebase. What will rebase do? It will incorporate the latest changes from master branch to feature 1 branch. So see, similarly, as we talked about conflicts, the conflicts could there be in case of rebasing also if same files are changed between two commits and Git is not able to resolve those changes itself. Then you will have to resolve the commits and complete the rebase. Okay, so the command to do this will be you have to switch to feature 1 branch and then you do git rebase master. This will rebase your feature 1 to the latest commit on master branch. Now let's understand this with the workflow for the scenario that we just saw, the change scenario, where you want to use fun1 function in feature 1 to test the changes. So till step 5, everything is same. So let's consider the state after step 5. So this was the state. Your feature 1 was on C3, master was one commit ahead at C4. You do git checkout feature 1 and then the command git rebase master. What will this do? This will take your feature 1 branch to C5. A new commit is created because you feature 1 has some more changes and it is rebased to the latest commit, that is C4 master. So everything that is in C4 will be in C5 along with the new changes that are being implemented in feature 1. Now you can do git merge. You can merge feature 1 to master, and you know feature 1 and master both will point to the commit C5 after merging. Yeah. So for more details on Git, refer to the SCM, gitscm.com. There's a book that has all the details about branching, merging, rebasing, and lot more details. Now, just a short introduction on how to use Git on IDEs. So almost all popular IDEs support Git. So either it is integrated by default or through plugins. So this is a snapshot taken from the Eclipse IDE. There's a plugin that you can install for the Eclipse to work with Git. So as it is a graphical user interface, it's very intuitive, and you can see the directory structure of your repository, something like this. And also there are options for all the commands that we have seen. So if you have understood the workflow, it would be very easy to work using GUI on IDEs. And IDEs also provide a way for command line if you want to use them. Now the third way is through GitHub. So this is an online Git repository hosting service as discussed. This provides a web-based graphical user interface to manage your Git project. created on GitHub, you would already be using this for your projects. So you would be already aware of some bits of it. It also provides you access control. You may have to give username and password to access your repository. Bug tracking that we'll see. Software feature requests we'll see. Task management, continuous integration, and you can also create wikis inside your project as a documentation. For more details, refer to the link